If you've ever been to an airport, you've probably heard the term lithium batteries. But have you ever wondered why you can't pack these batteries in your checked bags on airplanes? It's because sometimes lithium batteries can overheat and catch fire. Scary! But actually, you probably have lithium with you right now. It's in your phone, tablet, and even smartwatches. It's everywhere in the modern world. But where does all this lithium actually come from? Let's start from the beginning. Lithium is special because it forms in 3 different ways in the universe. To understand where the lithium in your phone came from, let's travel back 13.7 billion years to the Big Bang. In the beginning of the universe, protons and neutrons combined to form the lightest elements, mainly hydrogen, helium, and a small portion of lithium-7 and an even smaller portion of lithium-6. The lithium from way back then only makes a small amount of the lithium we use today. Second, there's cosmic ray fission. High-energy particles called cosmic rays zoom through space at incredible speeds. When these particles slam into heavier atoms like carbon, nitrogen, or oxygen, they split those atoms apart, creating more lithium-6 and lithium-7. Third, most lithium comes from dying low-mass stars smaller than our sun. When these stars get old, they expand and their outsides become cool. Once cool enough, helium atoms combine inside these dying stars to make an unstable atom that quickly changes into lithium. This lithium then gets blown out into space. About 4.6 billion years ago, all this space lithium was floating in a massive rotating cloud of dust and gas called a solar nebula. Suddenly, a shockwave from a nearby supernova explosion hit the cloud, causing it to collapse and start spinning counterclockwise, the same way our solar system rotates today. As it spun, most of the heavy matter like hydrogen, helium, and our lithium gravitated to the center and flattened into a disk, kind of like a frisbee. This flattened matter became our sun. The leftover material slowly cooled and condensed into small solid grains which stuck together through gravity, getting bigger until they formed all our rocky planets, including Earth. At this point, Earth was a hot molten ball. During what scientists call planetary differentiation, the planet began organizing itself into layers. Heavy materials like iron sank to form Earth's core, while lighter materials floated up. The mantle partially melted, forming Earth's crust. During this melting process, certain atoms that don't fit well into solid mineral structures get left behind in the liquid magma instead. These are called incompatible elements, and lithium is one of them. Scientists classify lithium as lithophile, meaning rock-loving. This tells us lithium hangs out in silicate and oxide minerals, which are the same types of rocks that make up most of Earth's crust. So, what should we look for to find lithium in Earth's crust? Lithium is mainly mined from massive, coarse-grained igneous rocks called pegmatites that formed in the final stages of magma cooling and crystallization. The largest deposit is a 2.5 billion year old deposit known as the Greenbushes pegmatite in Western Australia, with over 7 million tons of lithium reserves. The main mineral we're after is spodumene. So, how do we actually get lithium out of the ground and into our phones? There are 2 main methods today. The traditional approach involves hard rock mining of pegmatites like Greenbushes, basically digging up spodumene-rich rocks, crushing them, and then roasting them at super high temperatures with sulfuric acid to extract the lithium. But there's a newer, more environmentally friendly method called direct lithium extraction, or DLE, being developed at the Salton Sea in California. Geothermal power plants pump up superheated brine, basically really salty water, from underground reservoirs that are naturally rich in lithium. Instead of evaporating the water in massive ponds like traditional brine extraction, DLE uses special absorbent filters that selectively grab the lithium ions while letting everything else pass through. After extracting the lithium, the brine gets pumped back underground in a closed-loop system, and the whole process also generates electricity from the steam. It's way faster than traditional methods, hours instead of months, and uses much less water and land. Now, what exactly does lithium do in your phone, and why do we use lithium specifically? Lithium is perfect for phone batteries because it's the lightest metal on the periodic table. Lithium ions are tiny and carry a 1+ charge, which means lithium-ion batteries can store a huge amount of energy in a small, lightweight package, exactly what we need for smartphones. But there's one major problem with lithium batteries. Recycling them is really hard. Less than 5% of lithium-ion batteries get recycled globally because the process is expensive and complex. We definitely need better recycling infrastructure as we use more and more lithium-powered devices. Pretty amazing journey for a small element, right? Now next time you charge your phone, you'll know its long history.